So a healthcare CISO asked me the other day how we comply with the ISO 42001 requirements around data labeling, tagging, and provenance. So these are described in Annex A of the standard, specifically in sections 4 and 7. So I'm going to walk you through the 5 different ways that we label and categorize data at Stackaware and how we recommend that our customers do the same so that they can stay ISO 42001 compliant. So first of all, we're going to start with data classification. So at Stackaware, we have 6 different levels of classification. All right. So we start with public, and this should be pretty self-explanatory. This is anything that we are happy to make broadly available. There are no restrictions from a sensitivity perspective. We may still assert ownership over it from a copyright perspective, but we will make it widely available without any sort of restriction. The next is public personal data. We use this classification because under some regulations, like the EU's General Data Protection Regulation, information may be publicly available, but it is still regulated. It needs to be accurate. People can assert takedown requests, right to be forgotten requests on it. So we want to have a separate category for information that qualifies as personal data, and we use the GDPR as the standard for determining what is personal data and what is not. So next, we have confidential personal data. So public personal data would be something like my LinkedIn profile. My name is out there. That's personal data, but it's public. I have no problem with it being out there. Confidential personal data would be something like my social security number. That definitely is personal data, but I am not okay with it being out there in the open. So things like that we'd classify as confidential personal data. Next up would be confidential internal. So this is information that is not personal data that we want to maintain control of because of intellectual property considerations, competitive considerations, things like that. So for internal data, we as a company can control whether we want to release it or not without any sort of external coordination. So if we develop some sort of framework or code or algorithm, we would likely, and it was our property, we could classify it as confidential internal to begin with, but we could release it to the public without coordinating with anyone else. The next category that we have is confidential external. So as you might suspect, this is data that's similar to confidential internal information, so something that would be a trade secret that another party has provided to us under an obligation of confidentiality. So if we have signed an NDA with another party and they've given us information about their network, then that would be confidential external information from our perspective. They can classify it however they want, but that's from our perspective. And then the final category of data that we have is restricted. And this is really a catch-all term for these 3 classifications. So restricted data is anything that is not, we don't want to be publicly available. So it's just a handy way to refer to all of these things. And now within each category, you can even go deeper And you can say, under confidential personal data, you might want to separate out protected health information because that has different handling requirements under HIPAA than something like my social security number. And then under confidential internal data, you could separate out things like passwords or API keys. And you could separate those from business plans or things like that. You can really get as detailed as you want. We keep it at this level and we separate the different categories by how we handle the information. So in a nutshell, we have 6 categories of data classification at StackAware, and feel free to use that for your AI management system as well. Moving on, we're going to talk about categorization of data. So let me get rid of that marker. So this is important because one of the Annex A controls for 42001 requires that you describe the category of data. And we do that by labeling it in our backend in one of the following ways. So we have AI training. And as you might suspect, this is data that AI models are trained or fine-tuned on. This means that the weights will be embedded into the model, and we're using this to help develop it. The next category would be AI validation. And this is information or data that we use to tune a model after training to optimize the hyperparameters, things like that. And then the next category would be AI testing. As you might suspect, this is data that we use to confirm how effective the model is, whether it can generalize from the training data onto information that the model has never seen before. Additionally, we use information that we call diagnostic data. And this is different because we call it diagnostic testing, excuse me. And this is different because AI testing data is real data. It could potentially drive business decisions, where diagnostic testing data is fake data. It's not real. It could be made up names, places, numbers, information. So this would just be to confirm that a process is behaving as expected. So, 1 + 1 is 2 type things, where you wouldn't actually drive a business decision based on the answer that you got. You're just confirming that the process works correctly. Most people would just call this testing data, but we separate it from AI testing data because AI testing data could be real information. And then the final piece of the puzzle would be production data. Self-explanatory for those of you who work in IT. This is real-world data that we're using to drive real-world decisions, and we label it as such. So these are the data categorizations that we use for our ISO 42001 AI management system. Next up, we'll talk about intended use. So this is another required way that you describe your data when you're building your AI management system. And I'll use a different color marker. So for intended use, this should be pretty self-explanatory. And you can use data for multiple purposes. So for example, at StackAware, a lot of data we use for sales and marketing, we actually use for security and compliance. So our own data classification system is an example there. But intended use, we have 5 categories. We have human resources, and This could include personal data like, where someone lives, what their social security number is, if we needed to have that. It could also include things like, what their salary is, what their job title is, things like that. We also have admin and finance data. These are things like invoices, receipts, financial projections, things of that nature. We have sales and marketing. So these are things that are almost always intended to be publicly available, but it wouldn't necessarily have to be publicly available if we're submitting a contract under NDA or a bid under NDA to a customer. It could be confidential external while also being categorized as sales and marketing for sales and marketing purposes. We have product development. And this is information like specifications, user stories, things like that, which we use to drive development of things that we sell. And then finally, I mentioned security and compliance. This is information including logs of user activity. It could include credentials if we're storing those for some reason. And it could also include compliance standards that we've tracked and have in our database. So these are the 5 intended uses of data that we track for our ISO 42001 AI management system. Next, I am going to talk about data bias. So this is a topic that people express a lot of opinions about, and in my opinion, most of them are wrong, because there's no such thing as having AI without bias. So if you hear someone talk about bias-free AI, they're misspeaking, because there's no way you can have an AI model that generalizes from data it's never seen before without bias in the statistical sense. So elimination of bias is an unrealistic goal. Now, there are certain types of bias that are bad from a marketing or from a PR perspective, or that you disagree with on a moral level. And then there are also biases that are just frankly illegal, like under New York Local Law 144, you need to ensure that your employment screening systems have undergone a bias audit to ensure that they are not discriminating against certain types of protected classes. So that would be unlawful bias if your system is disadvantaging people who meet those certain characteristics. Now, at a broader level, tracking bias is difficult to do in a very in kind of a generalized way, and oftentimes you would have specific bias variance trade-offs for individual models. But on a broader level, we have 5 categories of bias when we are tracking data in our backend. So the first one is immaterial. Yeah, data bias. First one is immaterial. And self-explanatory here. This is where we understand everything. All data has some sort of bias. It came from somewhere, but we're just saying that for the purposes of whatever assessment we're making or whatever decision we're trying to make, it's not material. So this would be something like, math or geography. These things are not really in dispute. Things also like standards, laws, regulations, there's really no point in having a conversation about what the black and white of these things say. So we could consider, if we've got that information in our database, to be immaterially biased. Next up would be anecdotal. And this means that it's derived from a single event, observation, what have you. So if I am working with one customer and I see, one thing happen one time, and I decide that, hey, I want to record this as an observation for future engagements to make sure that, we're not making a similar mistake. I might record that as anecdotal, a social media post from a person saying, hey, I saw XYZ or I think XYZ, that's anecdotal information. The next up would be unrepresentative sample. And an example of this would be in your Slack channel for your incident response team. Most of the messages that you have are going to follow a certain structure. They're going to be, they're going to have the same syntax. They're going to talk about the same things, unless you actually have an incident in progress, in which case the messages are probably going to be a lot different. They're going to be much more rapid fire. They're going to be much more direct. They're going to be much more emotional in some cases. So if you just built an AI model trained only on those messages from an incident, it wouldn't generalize well necessarily on the information from kind of business as usual. So if we think that there's a chance there's an unrepresentative sample, then we would mark it accordingly. Next up would be conflict of interest. And this is when a person or organization is speaking about itself. So if, StackAware is talking about itself, I think you could probably say there's potential conflict of interest in anything I say about my company because I'm an interested party. So if a company issues a press release or describes how it's doing certain things, there's likely some sort of conflict of interest there. That doesn't mean it's wrong. It just means that the perspective that is provided has a potential interest that isn't being fully declared or is just kind of implicitly obvious from who's making the statement. And then the final piece that I want to add here is tagging AI generated data. And this can have multiple types of biases. So one piece of data can be labeled with basically everything, all these four. It can't also be immaterial if it has any of these four. But if an output from an AI model, from a generative AI tool, or even a predictive AI model, if we're using that for subsequent decision making, then we'd want to tag that as AI generated because it would necessarily inherit all of the biases of the underlying system that created it. So we want to keep track of that. And at StackAware, we do have a policy where we do not train or fine-tune models on AI-generated data to avoid the possibility of model collapse. That's something we are open to revisiting, but that's something we just don't do right now because of the potential risk there, so we want to keep track of it. So these are the 5 categories of data bias that we use in our AI management system. Moving on, we will talk about data quality. This is going to be a quick one, and I'm still working on a great way to describe data quality, but I haven't really been able to find one that is universally applicable and that wouldn't cause disagreements. So what I do is just use 3 qualitative descriptions. So high, that means it's from a known and trusted source, and it's unlikely to be corrupted in any sense of the word. So if you're just getting kind of weather readings from a weather station that has been reporting reliably for a long period of time, we could probably consider that to be high quality data. Now, if every so often, once in a blue moon, there are some corruptions in the data, maybe it reads that it's negative, 500 degrees Fahrenheit on one day, maybe, and then 10 years later it reads it's positive 500 degrees Fahrenheit, then we might have some reason to doubt the veracity of the data. So we might say, it's medium quality data. And most of the time it's right, but there could be some errors thrown in there. And then the final quality of data that we might have would be low quality data, and this would be something that you have reason to believe that it is inaccurate. So maybe some sort of measurement system has been malfunctioning, and it's outside a certain range of parameters that you would expect, and you can consistently see that it is misreporting or misrepresenting what's going on. In that case, we would call it low quality data. All right, so these are the 5 different ways in which we label and tag data at StackAware in order to stay ISO 42001 compliant. If you're interested in working with us to help build out your AI management system, please go to stackaware.com and let us know. We are the leading experts in ISO 42001 preparation and can help you surmount some of the common challenges that companies encounter when they're going through the process.